Hello and welcome to today's lesson, lesson 5.3, solving a system of equations by elimination. In our previous two lessons, we've solved system of equations by graphing and by using the substitution method. Today we're going to learn about the elimination method. Elimination method basically is telling us that we're going to eliminate one of the variables. So we're going to notice a relationship in our equations and will allow us to eliminate or get rid of one of the variables that we are set up with or starting with. So let's take a look here at our first example, and we'll just dive right in. So as I'm solving this system, I'm going to be using elimination. So you'll notice that there's not one variable is written for itself. It's not written in slope-intercept form. So there's really, I need to start thinking about this in a different way. And I do notice that I have one variable, this minus y, and a positive y, and they're opposites. So what I can do is combine them, my two equations. So I'm really just going to make this a giant plus sign. I call this kind of the big plus sign method, and combine our equations. So let's say x plus x is 2x. Negative y plus y is nothing, is 0. Bring down my equals. Negative 4 plus 10 is 6. And now I have just one variable, that x. I can solve for x. So x equals 3. Remember, the solution to any system is the point. So I'm always looking for that point, x comma y. So I've just gotten my x value of 3. Now, I can't necessarily do this. I can't, necessarily do it for the x value as well. I could go back and do it again, but I just basically need to pick one of these now and plug in my x. So I'm going to choose the second one because it's plus and I have a positive, and I could have chosen the first one. It doesn't matter as long as I pick one equation to find out the y value. So I know x plus y is 10. I always like working with addition and positive numbers, so that's the only reason I chose this one. I know x is 3 from right here. So 3 plus y is 10, so y equals 7. So I have my y value now. So my answer is 3, 7. Remember, the solution to any system is the point where the two lines intersect. So I have 3, 7. So I was able to eliminate one of the variables by combining. This is also sometimes referred to as the combination method. I'm combining the two equations to get rid of one of the variables. I chose the y values because they were opposites in this case. I'm always looking for those that have the same kind of coefficient and are opposites. So in example 2 here, I'm going to do a very similar thing. Just make my big plus sign. I notice I have opposites in the y's. So I can combine my x plus x is 2x. The y's cancel, or they eliminate each other. And negative 2 plus negative 14 is negative 16. So x equals negative 8. I gotta set up my answer over here. X comma y is going to be my answer. So I have that x value of negative 8. Now I'm looking for my y value. I'm just going to choose the first one because it's plus over here and it's a negative 2, which is a little bit friendlier than negative 8. So I have x plus 2, or x plus y, excuse me, equals negative 2. So let me just kind of start over here. So x plus y equals negative 2. I have negative 8 plus y is negative 2. Add 8 to both sides, so y equals 6. That is my point of intersection there of my two equations. My answer, my solution is negative 8, 6. Let's look at another one here, another system of equations that we'll solve using elimination. So I'm going to look, and my y's don't cancel in this one, and I have a positive 3 and a negative 3. So I can't necessarily use the big plus sign, but what I can use is the big minus sign. So I have 3x minus 3x is 0x's. Negative 4 minus 1 would be a negative 5y. 20 minus 10 is 10. So y equals a negative 2. I have my answer up here. X comma y. Always want to make sure I have that answer. So I have -2 for my y value. And now I need to pick which one of these I want to work with. I'm going to work with just the second one, just because it's a little more friendly looking to me. And once again, it doesn't matter. You can choose whichever one you'd like to choose. So I have 3x plus -2 equals 10. So 3x minus 2 equals 10. Add the 2 to both sides. 3x equals 12, so x equals 4. And that becomes just my second point up here of, excuse me, 4 comma -2. And if I plug it in, I would get 3 times 4 is 12 minus a -8, and I can add that, so 12 plus 8 is 20. That verifies. 12 minus 2 is 10. It checks out in both equations. Okay, let's look at our next one here. So once again, I don't have opposites that I'm starting with, but I do have the same coefficient of the 4y, so I can subtract them. 24x minus 12x is 12x. 4y minus 4y cancels, they eliminate. And 8, you have to be careful here, 8 minus -4 means minus a -4 means I'm going to add those together, so that's 12. So x equals 1. So I have my answer, x and y. So x is 1. I'm looking for my y value now. I'm going to just pick the first one because it's all positives, and I like working with those positive numbers, as you know by now. So I have 24x plus 4y equals 8. 24 times 1 plus 4y equals 8. 24 plus 4y equals 8. So 4y equals, subtract the 24 from both sides, gives me a -16. So I'm just going to move over a little bit. So 4y equals -16. So y equals -4. So I can take that, plug that in up here, and there's my solution to this system of equations using elimination. Now, could I rewritten these in slope-intercept form and graph them? Yes. Could I have rewritten it for one of the variables and did substitution? Yes. It would have been very laborious, intensive in order to do that, but I could have done it that way as well. So let's take a look here. So what method would we use to solve these? So if I'm looking at this equation here, this first one, 2x minus y is 6 and -2x plus 5y is 7. Do I want to graph these? Do I want to use elimination or use substitution? So I noticed that they're not written in slope-intercept form, so I probably don't want to graph them. I don't have one variable written for the other variable, but I do notice that I have the same opposite coefficients here in the x's, so I can use the elimination method. I have y equals 2x minus 5 and 7x plus 3y equals 12. Well, I have the first one is written so I can graph it pretty nicely, but the second one's not. But the first one's also written for one of the variables, so maybe I want to substitute that. Let's take a look here at this third one. Y equals -3/2 x plus 4 and y equals 1/3 x plus 2. Well, they're both written for a variable, so maybe I could substitute, but they're also written pretty nicely in slope-intercept form, so I could really graph those pretty easily too. So maybe I would do that. -8x plus 5y equals -24. 3x plus 5y equals 33. Well, they're not written in slope-intercept form like this one, so I don't want to graph them. They're not written for one of the variables, so I don't want to use substitution necessarily. So, but I do notice that 5y's are the same, so maybe I could use the elimination method as well for this one, and do that for this case here. So I would use elimination for both the first one and the last one because I have that coefficient of the 5y and the 2 and the -2x to do that. Excuse me, but once again, it's up to you and whatever method you're most comfortable with. I've presented to you now 3 different methods for doing this, and it's really about what you're most comfortable with using. So when a system is in this form, where I have those opposite coefficients in front of the y, I'm going to want to use elimination to solve those. So we solve the system using elimination. When the system is in the form of one of the variables written for the other variable, we're going to use substitution. And when they're written in slope-intercept form, that we're going to use graphing to solve them. So those are just kind of the easy ways to do that. So when you're presented with a system and you're asked to just solve it, you want to pick the method that works best for you. This is the recommendations that I have for you, but you know, it's really up to you and whatever you're most comfortable with, and how well you can rewrite equations and manipulate them to get what you need. So that is the end of today's lesson on solving systems of two equations using elimination. If you have any questions, please contact your teacher regarding this lesson. Also, make sure you watch your videos before doing your homework assignment and prior to taking your homework quiz for this section. I thank you for your time.